In this video, we're going to be talking about balancing chemical equations and talk about how it relates to the law of conservation of mass that we just covered in our last video. So balancing chemical equations, in doing so, our goal is to make it so that there is the same number of each element on both sides of the equation. Also, our final answer should be simplified. That is, we want the minimum number of each element on both sides of the chemical equation. So we shouldn't have, so even if it's balanced, we shouldn't have like a million of a certain atom on one side and a million of that same atom on the other side. We can probably simplify that. So we want the minimum number, we want it balanced, and we want the minimum number of each element. And I'm gonna go through some tips in some common mistakes that I've been seeing in students from last year that I had. So our first tip is going to be that, remember, our goal is to balance the chemical equations. We want, so in this example, we want the same number of sodiums and chlorines on the left side and the right side of the equation. So we notice here that we have one sodium on the left side and one on the right side. We have two chlorines on the left side and only one on the right side. So some people last year, some students said, okay, to balance this, I can just take a chlorine and just add it right here, and now I have a balanced chemical equation. And you're correct that you do have a balanced chemical equation now. However, this is not the correct way to balance the chemical equation. We can't just create chlorine out of thin air and add it to the products. In this chemical reaction, we mixed sodium and chlorine gas, and we get sodium chloride. We didn't get an additional chlorine by itself here. So we can't just create an element and just add it to what we're doing. So we cannot add an element or a compound. We can't just add something spontaneously. So make sure you're not doing that. Next thing is you cannot change an element or compound in the equation. What I mean by that is we have these subscripts, and this tells us how many of each element there is. I cannot remove the chlorine from here, or I couldn't, and I also cannot change the number of chlorines that I have here. So again, one sodium on the left side, one on the right side, two chlorines on the left side, only one on the right side. So some students said, okay, to balance this, I can just put a number right here. And again, this is balanced, but you changed the compound and you can't change the element. So we run into some problems here because NaCl2 does not exist. That's not a possible thing. That's only going to exist in fairy tale land. So we have to maintain whatever we're given. We have to use those elements and compounds. So I cannot change the compound. NaCl2 does not exist. It's completely different from NaCl. So we cannot just add a number to the subscript of any compound or element. I cannot do that. So that is another way that we cannot balance a chemical equation. Yes, the equation is going to be balanced if we do it that way, but it is not correct at all whatsoever. No credit. All right, lastly, what we can do. Is we can only change the number of each element or compound in the equation. So we said that we can't add an element here. We also can't change the compound, any of the compounds. So we can't do either of those. But what we could do is we can change the number of each element in the compound, or each element or compound in the chemical equation. So I can add a number right here, I can add a number right here, or I can add a number right here. And those are my three options on how to balance the equations, adding numbers in those three spaces. That's the only thing that I can do here. So let's keep that in mind as we move forward to some examples. So, however, sometimes the element or compound's state of matter is written in parentheses after the element or compound. This is not important for balancing the chemical equation, but be sure to rewrite these in your final answer. Some teachers are really strict because yeah, it's technically every elements or compounds going to have a state of matter, and especially in advanced chemistry classes, you're going to be a little bit more descriptive in saying that we have hydrogen gas here. We don't have liquid hydrogen or whatever. So all this means is we're going to have a number, or not a number, a letter written in parentheses after the element or compound, and that just tells you the state of matter. It serves absolutely no purpose for balancing the chemical equation. When we're balancing chemical equations, you're welcome to cross those out and forget about them temporarily. But my recommendation is just to remember to put them in your final answer, because some teachers are going to be kind of strict about that, and they want that to be in your final answer. So here are the states of matter. S is solid, L, a cursive L, is liquid, G is gas, and AQ is aqueous, which just means it's dissolved in water. All right, so not important at all for balancing the chemical equations. We're just going to remember to have that in our final answer. So now going about how to balance the chemical equations. Keeping in mind our goal is to have the same number of each element on each side of the equation, and there's a particular way that we have to go about doing it, which it means to write the numbers, change the number of each element by writing a different number in each of those areas. Also keeping in mind that if we don't have a number written here, we're assuming that there's 1. All right, so some of these, especially these easier ones, you might be able to just do in your head and kind of figure out without a particular method to doing it, which is totally fine. Some of you might find your own method that works best for you. I'm going to show you my method, and I would highly encourage us to at least consider using this method, because it will especially be helpful as we move on to more advanced problems later on. So let's go about how we're going to do this. The first thing we're going to do is we're going to write down the different elements that we have in this chemical equation. Every element that is on the left side of the equation, the reactants, is also going to be on the right side of the equation, the products. So here on the reactant side, I have hydrogen and I have oxygen. On the product side, I don't hardly even need to look at it, because I know that I'm going to have the exact same elements. There might be a different number before we balance them, but we are going to have the same elements. So we have H and we have O. I would also highly recommend that we write them in the same order, because it'll be less confusing. And you'll see what I mean going forward. But we have hydrogen and oxygen. What we are going to do is, again, write down the different elements that we have, and our next step is going to be count how many we have to start with. So I am going to count that I have 2 hydrogens here, because I have hydrogen bonded to another hydrogen. This is what the molecule looks like. But what we're concerned with is that we have 2 hydrogens. So H2 means that we have 2 hydrogens. O2, you might guess, means that we have 2 oxygens. Moving on to the product side, H2O, that's one molecule, and it looks like this if you're curious. This is what it looks like. And it might be helpful to be visually drawing out these atoms. We know how to draw all of these. We've done examples of all of these. But as we get to more complex problems, it's going to be very time consuming to be drawing out every single compound that we have. So I am suggesting that we get used to doing it from the numbers. So H2O, that's what it looks like, and it's made up of 2 hydrogens, denoted by this 2 right here in the subscript. And 1 oxygen, because there's no number written here, so we always assume no number to be 1. So again, 2 hydrogens, 1 oxygen. And now we recognize that this equation is unbalanced. Although hydrogens are currently balanced, so we're good with that, and we're not going to be concerned with hydrogen as of right now. But oxygen, we have 1 over here and 2 over here. So we need to see what we can do in order to balance those oxygens. And remember, our only option is to change the number written here, here, or here. if I need to, and I can't have less than 1, by the way. I can't just take away oxygen here. So if there's no number written, that means there's 1. So H2O, each H2O molecule has 1 oxygen. So if I add another H2O molecule, so we have 2 total H2O molecules, that is one way that I could, or that is really the only way here, that I can add the number of oxygens here to change it to balance out and be the same as the number on the reactant side. So I'm going to put a 2 here, and every time I change the number written in front of an element or compound, I'm going to recalculate the total number of each element on that entire side of the equation. So here I changed the number here, so on this entire side of the equation, I'm going to recalculate everything. So 2H2, that's going to give us 2 times 2, so we have 4 total hydrogens. And then I'm also going to recalculate the number of oxygens. 2 times 1, because there's no number in here, so we're going to assume it's 1. That means I now have 2 total oxygens. What that looks like is, again, I have hydrogen bonded to oxygen, and my dots, and then I have another one of those. So notice I have 4 total hydrogens and 2 total oxygens. So in case drawing it out helps. So we ran into this dilemma now. We now balanced out the oxygens, and because the only way to do so was to add another H2O. So oxygens are now balanced. We are good to go with oxygens. However, the dilemma is that by balancing the oxygens, we cause the hydrogens to become unbalanced. I have 4 hydrogens on this side, but only 2 on that side. So what can I do now to balance out the hydrogens? We are 1 step away from solving this question. Pause the video and think if you can think of a way we can balance out the hydrogens now. All right, hopefully we were able to figure that out. But if not, here's what we're doing. We are going to say, the only thing I can do is I can add a number here, here, or here. Or I can change the numbers in any of those spots. And if I need to add hydrogens to the left side of the equations, adding a number here is not going to help because this is oxygen. That's not hydrogen. So I need to add a number here. That's really my only option. And what number can I add right here to increase the number of hydrogens to 4 total hydrogens? Well, if I put a 2 here, that's going to be 2 times 2, or what it's going to look like is we're going to have H bonded to H and another H bonded to H because we have 2 total of them. And we get 1, 2, 3, 4 total hydrogens. We get 4 total hydrogens. And remember, every time you change a number in any of these compounds here or here, you're going to recalculate everything on that side of the equation. So I have 4 total hydrogens, and then just to make sure, I still only have 2 total oxygens. So that is how we solve a question like that. All right, so that is how we solve these. And we have 3 more examples that we're going to go through of these kind of more simple problems. And then we, in some other videos, we'll get through some more complicated examples. However, I'm going to save those other 3 problems for another video. So we went through the tips on how to solve this. We did 1 example. I'm going to save the next 3 examples for our next video.